where to begin. The important thing is where to stop. As a founder of the graduate group in ecology, it's a real pleasure to be able to give a talk to them after, I think I haven't given this seminar maybe for 15 years or so. I'm going to cover sort of a broad range of activities and go fairly quickly because, as usual, I have more slides than I should be showing. But I just, I love every one of them, and it's really hard to eliminate them. So I came to Davis in 1958. I only graduated from college in '52. And when I came into town, there wasn't a single light on, and tumbleweed was blowing down Main Street, and newspapers, and I swear there were hitching posts along this main street. But, that hasn't been confirmed. But I just never left Davis. It's a great place to go to school. It's a great place to teach at, and I've enjoyed half a century of it. Today, I want to begin by sort of quickly reviewing what I consider sort of a world water crisis. Water, not oil, is really essential for human livelihood. I think we're around 98% water. And we're suffering from a whole series of related interacting problems. As the price of oil goes up, more fertilizers are necessary to grow the food for a bludgeoning population. We don't hear much about population explosion since Ehrlich, about 40 years ago, presented the population bomb in Chicago. Actually, I came back from Lake Baikal to attend that. On top of that, we have this problem of carbon dioxide and methane increases, global warming, which is eutrophicating, greening the lakes of the world at a very distressing rate. This too then is tied in with the oil problem because to clean up water, you've got to use energy. Desalination, for instance, is a very heavy use of water. And further, the Green Revolution, which supplied the food supply, which has prevented serious famines in areas particularly like India over the years, is going to cost more and more and be harder and harder to obtain for developing nations. And on top of all this is a general decline in the quality of water. You go to China, I've been there about 4 times in the last 6 years. Everybody's drinking bottled water. Drinkable water is a real commodity throughout the world. People would love to feel that we don't have global warming. The oil companies spent small fortunes trying to convince us that the climate wasn't changing. But we find that carbon dioxide concentrations are now the highest that they've been in the last 800,000 years. And it's not just the fact that they've increased, it's the accelerating rate that they're increasing. If we look at 1990, we were increasing at about 1% per year. By 2000 to 2008, we were increasing by about 3.4%. And just look at these rates of increase over these 3 time periods. The rate of increase is accelerating. One of the other problems driving global warming, of course, is the loss of the Arctic ice pack. And this shows the decline in coverage over the years from 1970 up to 29 or 10. And I was always really impressed by a book I read at a tender age. It was called The Northwest Passage. Any of you read The Northwest Passage? The preface to it really struck me, and I think I still remember it. It says, on every side of us are men who search perpetually for their own personal Northwest Passage, risking fame, fortune, and life itself in this vain but hopeful quest. And who can say that they are not happier than wiser, duller folk who sit at home and with sour laughs deride the searchers of this fabled thoroughfare, this panacea of the affliction of the humdrum world. And now, if we look at passages, there were 69 of them between 1906 and 2010. We've now had 25 transects in 2010 alone. So the Northwest Passage is opening as the ice disappears. This shows white ice, which is 10 years or older, from April 1980 to April 2007. You can see that by 2007 we've lost a great deal of it, and we even have a really nice picture of it as a video as it breaks loose and floats off. Now, this loss of albedo, the reflection of sunlight back into the atmosphere, means that the oceans can absorb the heat directly. And we've seen lots of evidence of this already as hurricanes increase and possibly even the cluster of tornadoes has been a factor. Other elements of global warming that the oil companies have liked to ignore are, for example, the loss of the glaciers in the Himalayas. These feed the 70 mightiest rivers in Asia, and they are receding at a rapid rate. I can't help feeling that having a glacier named after you in the Antarctic is sort of a cold honor, particularly since it, interestingly enough, and you might think about this, why is the northern hemisphere warming so much more rapidly than the southern hemisphere? Anybody volunteer an answer for that? I'm kind of back to my teaching mode now.
More land mass, maybe?
More land mass in the northern hemisphere, and lots of water, which, as we know, is one of the great sources of heat absorption that we have. And that's the reason the land mass to water mass is so much greater in the northern hemisphere. And Alaska is warming at just an incredible rate, frightening rate. One of our Davis graduates, Katie Walter, grew up in Reno, came and did a master's degree at Lake Tahoe on the Eurasian milfoil, one of the invasive species at the Tahoe Keys, went off to Alaska to do her PhD, and then did it in the Russian Siberian Arctic. And here she's cut a hole through a lake and lit the methane that extends higher than this slide covers. As the tundra melts, the methane production is increasing at a drastic rate, and it's very uncomfortable to understand that methane is about 24 times as potent a greenhouse gas as carbon dioxide. The permafrost is melting. It's exposing all kinds of mammoth remains in the high Arctic already. And as the tundra melts, it gives up its water. The lakes are rising in Mongolia, and pretty soon that water held in the tundra will end up in the oceans. This problem of world water problems is nowhere more evident than in China. China has a really serious water problem. In this particular Lake Kunming, where I attended a conference in 2001, as you cross the lake, you could barely breathe because of the hydrogen sulfide produced by decaying organic material in the bottom of the lake. The water was actually black from this. They made the mistake of deciding they'd clean up the lake by dredging. Things buried, men want dug up again. And of course all they did was expose 1,000 years of organic pollution of this lake, and made things much worse. Same thing came up when I was an advisor at Oak Ridge, where there was the idea of digging up the Tennessee Valley lakes to remove the radiation that had seeped out of Oak Ridge during the atomic bomb uranium production. And you have a perfect cesium and a perfect mercury curve that corresponds there. So had they gone in and dredged those lakes to remove this material, they just would have exposed it. Same thing with mercury down in Gibraltar Reservoir on our west coast. It's got a load of mercury that you don't want to re-expose from the mercury mines along its side. This is Lake Biwa in Japan. I've been there several times. We're currently with Michio Kumagai producing a book on the impact of climatic change, which seems to be more agreeable to much of the political community than global warming. They just don't like global warming. Certainly Chevron, BP, Texaco and the like really made their dent on communication when they came down so successfully for quite a while, certainly through the former administration, on the impact of global warming. So we've all retreated more or less to climatic change. Maybe we're going into a new ice age. Another example of the loss of a very important water source, one of the largest lakes in the world really, was the Sea of Aral. And Stalin decided that he would grow cotton on the watershed and diverted the streams feeding the lake, Sea of Aral for cotton production. And as you can see, this is the literal dry zone has just steadily increased. The lake has now been split into two parts. 16,000 fishermen and cannery workers lost their jobs as the fishery just completely died. Another example of really poor water management. Thanks to Dr. Flado's activity at Lake Tahoe, we now have some really state-of-the-art oceanographic level buoys out on the lake, recording a whole series of variables down the water column, and supplied by ship to shore communication through cell phone technology. So you can just call up the buoy and find out exactly what's happening in the physical limnology down the water column. Do you have a chlorophyll sensor on that now?
On those buoys, no.
Anyway, that'll be a nice addition.
Biology's not that important.
People wonder why Tahoe is such a clear, clean lake, and most of them don't realize that it doesn't have very much of a watershed. Oh, wrong button. The white represents the 800 square kilometers of watershed, and the blue of the lake is some 500. So most highly productive lakes that can produce a lot of fish, turn green with algal growth, tend to have a 10-to-1 watershed to lake ratio. And Tahoe has only 1.6-to-1. So a lot of the water entering Tahoe falls directly on the lake as rain and snow. And you have a very low fertility, mainly decomposed granite and some volcanics around the lake, which don't provide a lot of dissolved nutrients. Hence, when I got to Tahoe in 1958 and 59, you could see down into the lake at this really important piece of limnological and oceanographic gear, the Secchi disc, invented by Father Secchi aboard the Immaculate Concepzione. The Pope actually had a navy in those days, and Father Secchi decided it was very important to see how much transparency you had, so he fitted a white canvas over a steel circle, lowered it into the water till it disappeared, pulled it back up again until he could see it again, and that has been Secchi depth ever since. And considering that the light goes down to the disc and back to your eye, it's a very good integration of transparency. And it's those values. I think if we did one thing right at Lake Tahoe in the early days, is that we kept it simple. People really could understand Secchi depth, whereas primary productivity didn't turn a lot of heads. The USGS had hoped to have this online for the Clinton Gore visit to the lake, but a few years later they were able to complete side scan sonar rendition of the lake. And if you look over here, this is Tahoma, and if we go back a slide, you can see this piece of real estate over on the west shore is gone. A major earthquake occurred, and this debris field actually developed from that earth slide into the lake, probably producing a tsunami possibly of 30 feet in elevation. The lesson there is if the ground starts to shake and you're at Tahoe, don't run down to watch the water recede. Head for the high ground as fast as you can, because such an event could easily occur again when we consider that there's a nice fault running right out of Tahoe City, another big fault out of Incline Village over here, and we do have a earthquake displacement of full 10 meters that the Scripps group were able to map with seismic gear. If we look at the history of Tahoe quickly and skip the gold mining, the loss of the entire Tahoe forest, the major perturbation of Lake Tahoe was actually in the 1860s when gold was discovered at Nevada City. And as a result, most of the basin was clear cut. We have a few small stands of old growth timber that they didn't get to, and these have been intensively studied by Professor Michael Barber, who's an old growth specialist. But after the gold ran out and the timber of the Tahoe Basin found its grave in the mines of the Comstock, the lake did make a recovery. The lumber mills were closed. We had a touristic railway utilizing the track and engine that had been used for the lumbering activity. Then a whole series of introduction. Crayfish, California crayfish, Paciphasticus lineisculus were introduced. An auto route encircled the lake. We had the end of the famous drought that brought so many from Arkansas and Kansas west. Kokanee salmon were introduced. A big event was the selection of Squaw Valley for the Olympics. The Tahoe Keys project was allowed by the Forest Service, not fully appreciating the importance of wetlands. And in fact, back in the early 60s, there wasn't a lot of appreciation of the importance of wetlands for nutrient removal from inflowing waters. Then the California and Nevada Department of Fish and Game decided that the Kokanee salmon, also an exotic introduction, the sockeye red salmon was introduced, and they thought they needed something more to eat. So they added the opossum shrimp, Mysis relicta, which proceeded to eliminate the main food supply for the kokanee, the cladocerans, daphnia, and bosmina. An example of an introduction that would not have been done had proper study been done about the impact of Mysis relicta on the natural phytoplankton population. I was able to convince the sanitary engineers of engineering science with a simple bioassay experiment that the sewage, even after tertiary treatment, had to be exported out of the basin. That was certainly my most important political victory and scientific victory at Tahoe. Shortly thereafter, the cladoceran population crashed. Here's a Nevada picture from 1860 of Glenbrook over on the east shore of Tahoe. You can see they just had pretty well butchered the forest. By 1980, it had recovered. This is exactly the same picture. You can see the mountain landscape. Unfortunately, it came back mainly as very crowded stands of white fir. So they deplete the water. They allow a bark beetle infestation. When a pine tree gets short of water, they aren't able to produce enough sap to expel beetle invaders. So in some stands at Tahoe, we have up to 70% of the fir dead or dying, at least in poor conditions. Fortunately, this has been a great water year, and that's going to help those stands. One of my students, Jason Snyder, has been working on an element that I think should help bring the world together to recognize that air pollution is a global problem. He's been studying the transport of Asian dust from the Gobi Desert in China across the Pacific to Lake Tahoe. He's been working extensively with one of the early investigators of Tahoe air pollution, Tom Cahill of the physics department, now retired. And this is a drum that turns very slowly and sucks in air through filters so that you can actually identify the Asian dust. And we've been able to analyze it for its phosphorus and trace element components. I'm not going to dwell on this. His thesis we're reading now, so ought to be available shortly, and some publications from it. This is the shot taken by Emery Christoph, who did the first photography of the Titanic. And he had an ROV, a remote operated vehicle, over here photographing our ROV, which has a video camera in it, in the toilet, the marine people call it the head, of the Tahoe steamer, which was scuttled in 1942, and we were able to find for the first time with this ROV about 20 years ago. And interestingly enough, this is the sediment that had accumulated in the wash basin. Notice how good shape the wood's in, the porcelain isn't stained, the pinch faucets are still shiny in this almost perfectly pH 7 water that fills the Tahoe Basin. Another of my students, Alan Havert, who's now a research scientist at the Desert Research Institute, took a series of cores. We actually bought this box coring device from Scripps, and then he punches out cores from the large sample that we bring up to the surface. And if we look, we're able then to reconstruct the sedimentation rate. That was sediment that had accumulated in that basin over the years. And back during Comstock, we were depositing 450 grams of sediment per square meter bottom. As the vegetation recovered in the basin, the sedimentation rate dropped down to 90 grams per square meter. And then with the post-Olympic, post-World War II development of the Tahoe Basin, with all the roads and all the development, the erosion rates accelerated up to 270, which is 3 times the sedimentation rate of the intervening period. We also were able, with the ROV, to find a forest in place off Camp Richards over on the southwest corner of the lake. And by carbon dating, we found that these trees are about 5,000 years old, comparing to the Little Ice Age. And they actually grew in place on the lake bottom, which indicates that there was a drought that probably lasted 300 to 400 years, if not longer, to grow these trees on what is now the lake bottom. There's no evidence that there was a major subsidence in this area as far as I know. So if we look at the problems at Tahoe, obviously the loss of transparency has caught the public attention. The League to Save Lake Tahoe has come up with the idea of Keep Tahoe Blue that you see on many a bumper sticker. There's been a major change in the biodiversity in the lake, largely through the introduction of exotic species. We've had a lot of loss of riparian and wetland habitat. The Tahoe Keys, for instance, was the largest wetland in the Sierra Nevada, and it was dug up, as you'll see, for the Tahoe Keys. Invasions of non-native biota. People have accidentally and intentionally added things like their aquariums to the Tahoe Keys, which have spread rapidly, particularly Eurasian milfoil, and now we have the Asian clam. And Turk is currently working on means of controlling particularly the Asian clam, and we're hopeful that the zebra mussel, which has been such a plague in the Midwest and has been moving west progressively doesn't get into Tahoe. So there's now a real attention to keeping the boats that are launched there clean. And of course we have toxics like PVCs, mercury, and we had a major series of pollution from MTBE, trimethyl-butyl ether, which was a additive that EPA forced on the gas economy, which was again a very unsound addition to the fuel supply, because it simply meant that you burn more gas, and the net improvement in emission was very, very small, if measurable. A lot of unfortunate things happened early on. As the ski areas went in, they just simply mowed down all the vegetation, and we had these major erosion events. This happens to be a shot of the not so heavenly Valley back in the late 60s and early 70s. They've been trying to get squaw carpet and other native plants back on those eroded sites ever since. Of course, when you're cruising along Lakeshore Boulevard here, you don't really see the extent of the road work that this shot shows that I took from a small plane. And these roads were put in without a lot of attention to erosion control, so they've been a pretty general source of sediments to the lake. And one of Dr. Schlotto's students showed quite convincingly how important these fine sediments are, which are so fine that they stay in suspension for a long time, contribute together with the algae to the loss of transparency of the lake. Dr. Robert Derlett and I have had a project going that's of course not popular with the cattlemen on the High Sierra. As you hike the High Sierra, you discover that where they're bringing cattle up and grazing above 5,000 feet, there's a major reduction in water quality. The cow patties are all over the place, and they trample around the small lakes, and of course contribute a lot of coliform bacteria. This is before grazing and after grazing, before and after, where we're measuring the E. coli's. So the solution, and more and more ecologists have to focus on not just doing studies but providing solutions. The Department of Environmental Science and Policy was actually created with the idea of doing more extensive applied ecology, and that has occurred. So we'd like to phase out cattle grazing in wilderness areas. If you hike through a wilderness area and then hit a national park, a U.S. Forest Service piece of land, the contrast is extreme. The cattle just do a lot of damage. And the national parks have been much better stewards of the High Sierra. So we'd like to get the cattle out above 5,000 feet and expand the national parks in the High Sierra into some of this Forest Service land. Of course, not popular with cattlemen who have had grazing rights for several generations. But again, they pay $3.50 a head to graze those cattle on public lands, and it costs the taxpayers over $8 a head to just manage the program. So it's one of those areas of waste that might be corrected. If we look at global warming just from the standpoint of Lake Tahoe, we find that the lake has increased a full degree over the last 30 years, and about 4 degrees in the surface waters. And if you don't believe in global warming, I think one should look carefully at this slide. This is the maximum daily temperatures. No significant trend, lots of variability. But if you look at the minimum temperatures, which are the nighttime temperatures, there's been a steady increase. And this simply demonstrates the blanketing effect of carbon dioxide and methane on heat loss from the Earth's surface, which of course is the background for global warming. If we look at warming rates at Lake Tahoe, 0.016 degrees centigrade per year, doesn't seem like a lot until you add a lot of years. And it just turns out that this is exactly the same rate that we have for the Zurich Sea in Switzerland. Whereas lakes to the north, Lake Washington, Lake 239 that David Schindler made famous in Canada, are warming at a much greater rate. One of my other former students, Dr. Now Associate Professor Sudeep Chandra at the University of Nevada, has been working with Turk member Marian Whitman on exotic introductions and their impact. Warm water fish have been added to the Tahoe Keys. People typically would take their aquaria up to the Tahoe Keys, and instead of taking the fish home with them at the end of the summer, they just dump them in. And since Eurasian milfoil was a particularly popular higher aquatic plant in aquaria, they were added to the Tahoe Keys and have spread rapidly around the lake, causing shoaling, warming, and with the shoaling and the aquatic plant growth, the warm water fish now are found all the way around the lake. This incidentally was a shot of the Tahoe Keys, Pope Marsh, on July the 13th in 1940. By 1967, they had dug the lake up and produced a Venice-type marina setup, and some 20 years later, they had built it out and had channelized the upper Truckee River, which provides about 25% of the inflow to Tahoe, into this single channel, having lost all the filtering and nutrient removal capacity of this wetland. Certainly one of the most serious perturbations of the Tahoe Basin since the Comstock mining, and one which certainly wouldn't be allowed today under current knowledge of the importance of wetland plants. This is Eurasian milfoil. The Tahoe Keys spends about $100,000 a year mowing this and removing it. And when they mow it, there are a lot of fragments left over, and Tahoe seshes. The wind blows in one direction, the water gets built up downwind. When the wind stops, it rocks back and forth at about 13 hours. So water flows into the Tahoe Keys, picks up these fragments of milfoil, and distribute them all around the Tahoe Basin. Here is a show of what have been introduced. Almost everything: brown trout, rainbow trout, brook trout. The lake trout is the dominant introduction now. Crayfish got in, kokanee salmon in the late 40s, early 50s. And then the Mysis relicta possum shrimp introduction, water milfoil, and large and smallmouth bass. What we lost were the native cutthroat trout, which came up from Pyramid Lake to spawn in the tributaries of Lake Tahoe, and as I mentioned, the cladoceran, Daphnia, and bosmina, the other cladoceran. Now, this is a close-up of the opossum shrimp, Mysis relicta. Those big eyes enable it to operate very low light concentrations, and they drop into the abyss, the dark waters of Tahoe, every day. They're negatively phototactic, so the sight-feeding kokanee that they were introduced to feed actually never get a shot at them. This is bosmina. People did not believe that Tahoe was changing from my transparency measurements. You know, the lake looked plenty clear, and the fact that it was losing a foot of transparency per year certainly made no impression on a largely shore-based population. But when Tahoe began to develop this periphyton or attached algal growth, this is Gomphoneus herculeum, a stalked diatom which attaches to the bottom. People began to slip and slide around on this slimy subsurface. They began to recognize that Tahoe was changing, and as soon as solar radiation begins to increase in April and May, it bleaches white. It looks like it snowed on the bottom here, doesn't it? It breaks loose and comes up as a noxious decaying mat near shore, and in this case in the Tahoe boat works. Primary productivity, which has been kind of my thing over the years, has increased at about 5% per year as nutrients increased in the lake from an increasingly disturbed watershed. We were able to export the sewage out of the basin, or I don't think I'd be giving this lecture about Tahoe's condition today. Transparency varies greatly, and largely on the basis of how cold a winter we have and how much mixing occurs. Nutrients are constantly being regenerated in the deeper portion of the lake as algal cells, fish, zooplankton, and so on die, fall into the deep waters of Tahoe's 500 meters deep. It's about the 11th, as I recall, it's the 11th deepest lake in the world. But Tahoe doesn't mix every year. It takes a very cold winter and a very strong winter storm to turn that water all the way over. Many students, in fact, I always start my first lecture off with asking the students whether they could mix warmer water, lighter water, with more or less energy than colder, heavier water. And it's counterintuitive. 98% of them always say it's going to take less energy to mix the warmer water. And I've drawn a couple of containers on the board, one with 4-degree and 5-degree water, and then 25 and 26-degree water. And it turns out that it takes 30 times as much energy to mix 25 and 26-degree water as it does to mix 4 and 5-degree water, because the density difference between 25 and 26 is 30 times the density difference between 4 and 5-degree water. So it takes a cold winter and a late winter storm to mix Tahoe. The other thing that happens is when we have droughts, transparency increases because nutrient-rich water and sediment particles aren't resuspended in the upper water. This shows 1983 to 1988, a politician took this data to Washington and tried to prevent us from getting Burton Santini funding for research on the lake on the grounds that Goldman had solved the problems at Tahoe, no need for any more research. So I had to write a white paper, deliver it to Washington on the matter. We've had another similar event from 1997 to 2002 during a similar drought period where we weren't getting complete mixing. Taking the same data, Turk has smoothed this a bit, and even with these drought periods shown here, we're hoping that this increase or the decrease in transparency is leveling off, and we'll begin to see a gradual improvement with all of the land management efforts that Dr. Schlotto and John Reuter have been accomplishing in the basin. We are beginning to lose oxygen. I'm going to speed up now. And I wanted to put a plug in for Castle Lake, which has a full 53 years of data. And we just completed our 53rd oversnow field trip to Castle Lake this last weekend. The snowpack was just incredible. We had to cut a long way through the snowpack to get to the ice, to get to the water, to do our winter sampling. I also like to stress in this talk the importance of getting to the younger generation. And my wife Nancy's daughter is right over there. She attended one of the children's days that are now, I guess, in the 11th year. We set this up at Sand Harbor, where the kids came in, the graduate students set up displays. We now have the League, the Tahoe Bike Hall Institute, the USGS also participating in this. We give them all t-shirts, pop and pizza. Take them in, at this time we took them all out on one of the major vessels, tourist vessels on the lake, pulled up with our research boat, the John LeConte, handed live samples of zooplankton aboard, and it was quite a hit. And the children then go home and talk to their parents, and you have a whole new generation of conservation minded youngsters. And of course, biopolitical activity at Tahoe, which in some ways helped put Davis on the map, since it got worldwide coverage. We had Clinton and Gore both out on the boat for an hour, and he's saying, President Clinton and Vice President Al Gore examined Lake Tahoe water samples with lake researcher Charles Goldman Wright. The minute we got to the boat, I got my biology 101 course, Clinton said. Well, regardless of your view of Clinton, I have never met a more charismatic individual in my life. I mean, when he talks to you, you feel like there's just absolutely nobody else. Most politicians, and my mother ran for Congress twice, so I saw a few of them back in Illinois, they have their hand on your shoulder and they're looking around to see who they really should be talking to. But Clinton has this incredible ability to just focus, and he's really smart. And Gore wasn't a bit wooden either on this. I think when you're vice president, what do? You just got to stand there behind the president. You can't say anything or do anything. And I think that's how the press figured Gore was wooden. And of course, last but not least, I spent at least 4 years of my career, maybe 5, helping to raise the funds to build the Turk Center. And we now have a fabulous crew of researchers, many of them holdovers from the Tahoe Research Group. John Reuter is the associate director, one of my former students. Bob Richards was captain of our research boat for many years, and you already know that Jeff Schlotto is the boss. It's been a very good group, and we've had, I think, a very successful and continuing run on research at Lake Tahoe. J.T. Ravis, who contributed this picture, gave a whole series of really good pictures to Turk. And if you have not been up to the Turk facility at Tahoe, you're all, of course, invited. We have a whole series of docents there to show you around. The first floor was essentially paid for by what was the Drugstore Long Foundation, now sold out to CVS, who gave us $2 million, and we were able to put a very nice visitor center on the first floor, classrooms on the second, and our labs on the third. I'm just going to end up with what is really a popular talk. I can get this many in for a talk like this, but I can get 1,000 in if you want to give a talk about USOs, unidentified swimming objects. What about USOs? Have you ever seen one? They're constantly reported. Do you think they're real? Here is a short tutorial. And if we go back to Ulysses Aldrovandi, his students published a really interesting book that he had started, showing what people used to think were sea monsters. The original picture of the Loch Ness Monster was, of course, a forgery. Some say that's an elephant actually going across a river that was inserted with its trunk out of the water. Others say it was a float. The man on his deathbed admitted it was a fraud. But I got a trip to Loch Ness by legendary Nessie hunter Robert Raines from MIT. And even after a week, he died recently, I was not able to ascertain whether he believed in the Loch Ness Monster or was just keeping it going. But he brought a $1 million piece of equipment over. I'm launching it there. And he said we were looking for the remnants of Nessie. There's Nancy, but you can see it's really important commercial stuff there at Loch Ness. A lot of Scotch whiskey and lots of Nessies. And of course there are sea monsters. This is an oarfish, 400 pounds, 20 to 30 feet long, that was actually collected. And we have our own Davis student, Zeb Hogan, who's been collecting monster fish all over the world. This is a taimen collected from a Mongolian river, and they can reach 200 pounds. So they get big and they eat mice and things like that. With that, I will quit. Yes, Alicia.
Well, how many other lakes in the world get so much financial support, so much protection, so much research going on there?
Good question. We're trying to generate that for Audubon now, which is a beautiful mountain lake, but we'll never be able to achieve that sort of support. Partly, it's the fact that a really elitist group of San Franciscans settled along the west shore, and with their beautiful property, didn't want to see the lake decline in quality. And they set up the League to Save Lake Tahoe, which now has a better budget, I think, than our research program probably. And they actually gave us a modest contribution to build the facility. But keep in mind that Frank Sinatra and the Rat Pack hung up at the North Shore. Tahoe was getting a lot of publicity before we arrived. And then, since it's Forest Service land, they're the 90-pound gorilla getting most of the money that they portion out as they see fit for research and forest practices work. So it's a rather unique situation. Plus, it's the entire water supply for Reno, Nevada. And that gives it, and keep in mind that Senator Reed is the leading Senate senator, and he has quite a bit of clout and has been responsible for, well, he was responsible actually for getting Clinton and Gore to come visit Tahoe. That was some sort of a political promise that he paid off on. And as a result, Clinton said they'd spend $1 billion over 20 years to fix Tahoe. And I don't know how much of that we've gone through. Recent allocations have been greatly reduced. But I think that's the reason. It's just had a lot of publicity for a lot of years. And it's been an important gambling center and an important vacation center for a lot of people. So it's, that's why. Yes.
So, I mentioned when we talked before your seminar here, that you gave a talk about 25 years ago about it was long-term data on Tahoe, and I wondered if you could speak to that some. I was so impressed with that because
well,
now you have 50 years instead of 25 years.
Actually, Lake Tahoe and Castle Lake probably have the longest, best data sets on the West Coast. And without long-term data in ecology, the variations in weather alone make it very hard to come to positive conclusions about what data is showing. And without that long data set, we couldn't have certainly concluded that Tahoe was warming. But it's a wonderful condenser, really, for climatic change. So I guess one of the take-home messages, I'm glad you asked this question, is that long-term data in ecology is extremely important if you're going to make the right decisions in terms of land and habitat management. Yes.
So what is the outlook for Tahoe in the context of climate change over the next 50 years?
Well, the worst news is that mixing is likely to become less and less frequent. That means it'll be very clear, stay clear at the surface. People will conclude it's improving, but then when it mixes, it will have accumulated more and more nutrients, so you'll get bigger fluctuations in productivity. The other thing is that if it doesn't mix, then eventually it'll become more and more like a tropical lake, and we'll lose the oxygen at the sediment-water interface, and we'll begin to lose phosphorus, a major limiting factor now, from the sediments. Ferric phosphate will switch back to ferrous, and out it'll come into the water column, and eutrophication will proceed, and the lake trout, which depend on the bottom of the lake for their lifestyle, along with the sculpins, will begin to disappear.
So Charles, along those lines, I guess what people often worry about for entire systems is whether or not there is a tipping point, a regime shift. Do you have a sense of mechanisms here to worry about? I mean, it sounds like what you were just saying could easily do that.
Yeah, I think climate change could easily be the tipping point for Tahoe. fortunately, the sewage has been going out of the basin since the late 60s, when we convinced them they had to export the sewage. Simply by putting their tertiary treatment water into mid-lake water, we turned it green in 3 days in a bioassay. And that convinced this elite group of sanitary engineers from Stanford, Berkeley, and Wisconsin that they couldn't put the sewage after tertiary treatment back into the lake. So that was a really important slowing. Science has certainly slowed down the demise of Lake Tahoe. As time progresses and we get the erosion under control, we're able to get more of the runoff into settling ponds and artificial wetlands. We may be able to turn the tide, level off this declining transparency, and show some real improvement. And then we might go into a glacial age. Tahoe will cool down again and it'll mix more. That'll fix it.
On a somewhat hopeful note, yes, thank you.
Yeah, thank you. Where to begin. The important thing is where to stop. As a founder of the graduate group in ecology, it's a real pleasure to be able to give a talk to them after, I think I haven't given this seminar maybe for 15 years or so. I'm going to cover sort of a broad range of activities and go fairly quickly because as usual I have more slides than I should be showing, but I just, I love every one of them and it's really hard to eliminate them. So I came to Davis in 1958. I only graduated from college in '52. And when I came into town, there wasn't a single light on, and tumbleweed was blowing down Main Street and newspapers, and I swear there were hitching posts along this main street. That hasn't been confirmed. But I just never left Davis. It's a great place to go to school. It's a great place to teach at, and I've enjoyed half a century of it. Today, cent per year. By 2000 to 2008, we were increasing by about 3.4%. And just look at these rates of increase over these 3 time periods. The rate of increase is accelerating. One of the other problems driving global warming, of course, is the loss of the Arctic ice pack. And this shows the decline in coverage over the years from 1970 up to 29 or 10. And I was always really impressed by a book I read at a tender age. It was called The Northwest Passage. Any of you read The Northwest Passage? The preface to it really struck me, and I think I still remember it. It says, on every side of us are men who search perpetually for their own personal Northwest Passage, risking fame, fortune, and life itself in this vain but hopeful quest. And who can say that they are not happier than wiser, duller folk who sit at home and with sour laughs deride. I want to begin by sort of quickly reviewing what I consider sort of a world water crisis. Water, not oil, is really essential for human livelihood. I think we're around 98% water. And we're suffering from a whole series of related interacting problems. As the price of oil goes up, more fertilizers are necessary to grow the food for a bludgeoning population. We don't hear much about population explosion since Ehrlich, about 40 years ago, presented the population bomb in Chicago. Actually, I came back from Lake Baikal to attend that. On top of that, we have this problem of carbon dioxide and methane increases, global warming, which is eutrophicating, greening the lakes of the world at a very distressing rate. This too then is tied in with the oil problem, because to clean up water you've got to use energy. Desalination, the searchers of this fabled thoroughfare, this panacea of the affliction of the humdrum world. And now, if we look at passages, there were 69 of them between 1906 and 2010. We've now had 25 transects in 2010 alone. So the Northwest Passage is opening as the ice disappears. This shows white ice, which is 10 years or older, from April 1980 to April 2007. You can see that by 2007 we've lost a great deal of it, and we even have a really nice picture of it as a video as it breaks loose and floats off. Now, this loss of albedo, the reflection of sunlight back into the atmosphere, means that the oceans can absorb the heat directly. And we've seen lots of evidence of this already, as hurricanes, for instance, is a very heavy use of water. And further, the Green Revolution, which supplied the food supply, which has prevented serious famines in areas particularly like India over the years, is going to cost more and more and be harder and harder to obtain for developing nations. And on top of all this is a general decline in the quality of water. You go to China, I've been there about 4 times in the last 6 years. Everybody's drinking bottled water. Drinkable water is a real commodity throughout the world. People would love to feel that we don't have global warming. The oil companies spent small fortunes trying to convince us that the climate wasn't changing. But we find that carbon dioxide concentrations are now the highest that they've been in the last 800,000 years. And it's not just the fact that they've increased, it's the accelerating rate that they're increasing. If we look at 1990, we were increasing at about 1%.